Alright, so there's the first one I asked you guys to do as homework tonight. You're going to graph this rational function. One thing I'm going to do to start with this rational function is I'm going to go ahead and get the numerator and denominator in factored form to see if anything cancels out, if there are any holes in the graph. So if you're going to factor the numerator, it's x minus 3, x plus 1. You can take an x out of the denominator, and you get x, and quantity x minus 3. So you're kind of thinking, oh, those are going to go away. Just for the purpose of graphing, if those cancel out, we're talking about there's a hole in the graph at x equals 3. Now the y-coordinate of the hole in the graph, well, take 3 and plug it back into the remaining x's. So up top you'd have 3 plus 1. Down below you'd have 3. So that's 4/3. So that gives you the y-coordinate of the hole in the graph. Okay, so we got that. Kind of get rid of that guy. Alright, so this graph has one hole in it. These are, and for all intensive purposes, these can go away here. I'm going to get rid of this equal sign because they're not really, straight equivalent anymore. They would be, equal so long as we said, hey, x does not equal 3. Blank equals blank so long as x does not equal 3. So, this is kind of that post-cancellation. Now we're going to look for our intercepts, okay? So the x-intercept, okay, those are the zeros of the numerator. Well, that's -1, 0. The y-intercept, well, what happens when you plug 0 in for x? If x is 0, you get 0 plus 1 over 0, which is 1 divided by 0. 1 divided by 0 is, oh no, it's undefined. You're thinking, so that really isn't, there is no y-intercept. This is undefined. 0, comma, undefined, meaning no y-intercept. You'll notice, next thing we do would be vertical asymptotes. Symptotes. Vertical asymptotes. Those are the zeros of the denominator post-cancellation. Okay, well these are x equals equations. So the zeros of the denominator are, well, there's just one of them, x equals 0. Okay. So, which explains why there's no y-intercept if there's a vertical asymptote at x equals 0. Okay, hole intercepts, vertical asymptotes, and behavior. So we're going to divide the numerator by the denominator. We're going to look at what the quotient is. So x into x plus 1, there's a 1. So you subtract those and you bring the 1 down. X does not go into 1. That would be the remainder. The quotient, however, is 1. So our end behavior model is y equals the quotient, which is 1. So now we go to putting this all together on a graph. So we can handle that. So get rid of this stuff. This is all my kind of important information I'm going to use to help make the graph. Let's tuck this stuff up here. Okay, so I got to sketch a graph. Let's see, the intercepts. Let's see, I got x-intercept at -1, 0. Put some marks on our coordinate plane. This is the x-axis, this is the y-axis. Okay, so an x-intercept at check -1, 0. Right there. Well, no, there is no y-intercept. Okay. Vertical asymptote at x equals 0. Okay, so that is vertical asymptote right here. Okay, check. End behavior is y equals 1. Okay, y equals 1, that's this line right here. That horizontal line. So check that guy. We haven't done the hole in the graph. That's at the point 3 4/3. 1, 2, 3, and 4/3. So there's a hole in the graph. 3 4/3 be about right here. So you really have two halves to this graph. You got the half that's to the right of the vertical asymptote, and then you have the graph that's to the left of the vertical asymptote. So we'll do the right half first. Okay. Well, as far as the right half goes, let's move this. As far as the right half goes, you kind of have two options, right? You think, well, we're either going to have something like this guy or something like this one. So we first need to figure out, where does it start? Do I need to start the graph up here and come down, or down here and be going up? So, well, if you plug in a number just to the right of your vertical asymptote, like let's say 0.5, okay? If you plug 0.5 into your function, let's look at what the y-coordinate is. Okay? So when x is 0.5, the simplified version would be nice right now. I think we had, let's see, it was, I erased it. Was it x minus 3, x plus 1? On the bottom was x minus 3. Alright, sorry, I had to pause it real quick. So we were working on trying to get the shape of this graph. So I was suggesting we plug in like 0.5 to see, well, these cancel, 0.5 to see if the graph originates from down here and comes up and then hugs the end behavior asymptote, the horizontal asymptote there, or if it starts from the top and goes down. It comes through here. And we'll also talk about, the thinking that goes behind. Well, we end up hugging that end behavior asymptote, the horizontal asymptote there. And okay, well, what kind of thinking can we go through to figure out, what kind of work can we do to figure out if we hug that asymptote, the horizontal one, the dashed green line, what kind of work can we do to figure out if we close on that thing from the top or from the bottom? But it so happens when you plug 0.5 into your equation, you get 0.5 into that thing, you get, let's see, 0.5 plus 1 over 0.5, so you get a positive result. Okay, so when x is 0.5, you get, let's see, 1.5 over 0.5, which is 3. So when x is 0.5, you get 3. So when I put that point there, now that's going to help me kind of get a clear indication. Oh, my graph starts from up here, goes down through this point. Now I know it's going to go through, I have this hole in the graph. Okay, so it comes through there, comes out this hole. Now, you can cross an end behavior asymptote, right? You don't cross it in the end, but you can cross it in the middle. So we're going to do some work to figure out, okay, now do I just hug this asymptote from the top side, or do I actually dip below it and then hug it from the bottom side? So we got to decide. Well, okay, if we hug this asymptote from the top side, when we plug in a number like 100, then the y-coordinate at 100 is going to be just over the dashed green line. And if we hug the asymptote from the bottom, the y value when x is 100 should be just under 1. And I'm using 1 because, well, that dashed green line is that's the line y equals 1. So let's plug 100 in to our equation, just how we did with 0.5, and you get 100 plus 1 over 100. Well, how much is that? Well, that's just over 1. Oh, okay. So the bigger x is, you'll notice the top of this fraction is always going to be bigger than the bottom, and you're going to, that fraction will get closer to 1 from the top side, So we got the right hand side of the graph. Now the left hand, well, we have our x-intercept right here. So we know the curve passes through there. So, could the graph do this? Could it start up here, come down through there, and then cross the x? No, it couldn't do that because that would make another x-intercept. So it's not that one. So really our only option for the bottom is it's going to start from the bottom, pass through here. Okay, now you got to decide. Does it hug that end behavior asymptote from the bottom or from the top? Because maybe the graph, maybe it goes dips up and then comes back down. So we need to decide if it hugs it from the top or the bottom. So I know this much. So let's plug in a number like negative, let's say this is negative 10 out here, okay? So we want to know, at negative 10, is the y value less than 1 or is it more than 1? Because if it's less than 1, we're going to say, well, this is going to hug it from the bottom. If it's more than 1, we'll say it's going to hug it from the top. So if I plug negative 10 into my function, I get negative 10 plus 1 over negative 10, which is negative 9 over negative 10, which is less than 1. 9/10 is less than 1. So it's going to hug it from the bottom. So I'm fine with you just following this from the bottom here. Okay. Now I hate to say too much, but does that mean that the graph couldn't have gone above it and then back below it and then hugged it from the bottom? No, that would have been a possibility. You just need to make sure as you draw it, this thing, okay, your curve is following the asymptote from the bottom. From the bottom side, you are getting closer to that y equals 1 line. So this would be a great answer right here, the graph you're looking at for number 1. Now we jump to number 2. Okay, we jump to number 2. I got to pull up the question. This is kind of a fun one. X over x squared minus 9, which is the same as x over x plus 3, x minus 3. We're dealing with the difference of squares. Okay, let's see. Nothing cancels. No holes in the graph. No holes in the graph. We have some vertical asymptotes. Vertical asymptotes. That's the zeros of the denominator. So x equals negative 3. X equals 3. Negative 3. 3. End behavior. Well, you'll notice if you expand out the denominator, you'll get an x squared. And there's no way x squared is going into x, so the quotient would be 0. So if you graph that end behavior, right, y equals 0, you get this guy here. Have those dashed green lines, see if we can make them any more obvious. So there's really 3 sections of the graph. The right, over here, the middle, and the left. So we got to do some analysis to figure out what each of those sections looks like. We also should look at the intercepts, right? That's going to help. So intercepts. Okay, zeros of the numerator are the x-intercepts. Well, that's when x is zeros of the numerator. Oh, 0, comma, 0. Now the y-intercepts. Well, that's when you plug in 0 for x. What do you get? Well, when you plug in 0 for x, we just discussed, you get 0 for y. So the x-intercept and the y-intercept are the same point. It's because they're the origin. So our graph contains this point right here, 0, 0. No holes in the graph, so that's all we know. Now the middle section of the graph is, I think, the toughest because there are so many options. Your middle section may, we're going to do analysis to figure out, maybe your middle section looks like this. Or maybe your middle section looks like this. Or maybe it looks like this. Or finally, I don't know if I've done this one, maybe it looks like this. So we're going to have to decide which of those it is. Now, I'm trying to decide, okay, does the graph, is it up here or is it down here? Well, if I plug a number close to 3 in, let's say like, 2.9, okay? If I plug 2.9 in, do I get a point up here or do I get a point down here? That's going to help me. So let's plug 2.9 into our function. So you have 2.9 over 2.9, plus 3 times 2.9 minus 3. Well, the top's 2.9, and the bottom is, 5.9 times negative 0.1. So that's a negative answer. Negative number. So this first section of the graph, we were trying to debate, does the graph is it up here or is it the one down here? Well, because when we plugged in 2.9 we got a negative, it's going to be this guy right here. So the graph starts down here. It's going to go through the origin. Okay, now we have to decide. Does the graph then go up here or does it go down here? So you're going to pick a test point, right? Like negative 2.9. If negative 2.9 gives you a positive, it's up there. If negative 2.9 gives you a negative, it's down there. So negative 2.9. So I can just modify this work. Negative, negative, negative. So the top is negative 2.9. The bottom will be 0.1 times a negative number, negative 5.9. So a negative, so the bottom is negative, the top is negative, a negative divided by negative is a positive. So it's this variation here. Okay, cool. So then, let's go to the left-hand piece. You got to decide, is it this guy? Whoops. Is it this one? We know we can't cross the x-axis because we don't have x-intercepts. Or is it this one? Well, we just have to pick a number to the left of negative 3 and see if we get a positive answer. If we do, it'll be up there. If we get a negative answer, it'll be down there. So let's say you picked negative 3.1. So let's plug negative 3.1 in. Make some space here. So negative 3.1. We can do this. Part of this is just a battle of you're just trying to persevere here and stay focused. There's so much going on. So negative 3.1 over negative 3.1 plus 3 times negative 3.1 minus 3. Okay, the top is obviously a negative. The bottom is a negative times a negative, which is a positive. So negative divided by positive is negative. So it's got to be this guy here. Okay, we go to the right-hand side. So I'm going to pick a number like, even 4 would be fine. Okay, so 4. Does 4 produce a positive result or a negative result? If 4 produces positive, it'll be this graph. If 4 produces negative, it'll be this one. So 4 into my function. 4 over 4 plus 3 times 4 minus 3. You got positive over positive times positive. It's all positive. Now you say, do I cross this end behavior asymptote? You know, no, I never do, because I don't have any additional x-intercepts. I mean, I do here because there's an x-intercept, but nowhere else. And that's it. So good job. Thanks a lot. That was a lengthy problem, but thanks for sticking with it.